Alright, Krazifizix, Maths and Science Clinic, Edutainment Clinic. Check us on our website, krazifizix.org.za. Alright, this is part C of the video. We have to break these videos down in an hour sessions, and we went through part A. Part A was question number 1 to question number 4. Part B is question 5 to 10, and part C will just be question 11. So this is going to be a very short session because we are only dealing with photoelectric effects. Alright, which gives me a bit of chance to explain a few things further. Alright, so let's look at question 11. Oh, by the way, we're dealing with May, June 2018 paper 1, in case you don't know which paper. That's the paper 1. Go to www.education.gov.za to download the paper and walk through with us. It will be awesome, and it will assist you in getting ready for your exam. All right. Okay. Question number 11. A group of students investigate the relationship between the work function of different metals and the maximum kinetic energy of the ejected electrons when the metals are irradiated with a light of single frequency. This alone describes photoelectric effect. Photoelectric effect, which describes or which exemplifies the particle nature of matter. Matter can behave either as a wave or as a particle. This is a particle. Sometimes it's asked, and it's 1 mark there. Alright, what are the definitions I need to know? I need to know my work function. I need to know my threshold frequency. I need to know the definition of a photon. Alright, now these are very, very important definitions, and I must be able to define photoelectric effect itself. Alright, so check your definition pages supplied to you at schools, and you'll be able to deal with all of this. Okay, let's answer the question. Define the term work function. Work function. Alright, what is work function? It is, the symbol is that it is the minimum amount of energy. Minimum amount of energy. Alright, that is needed or required to either eject or emit an electron, alright, from the surface of a metal. Great. 2 marks. Now, during the investigation, ultraviolet rays, now they give us a wavelength. Let's go write that down. Wavelength is 2 times 10 to the power negative 8 meters, are allowed to fall on different metal plates. The corresponding maximum kinetic energies of ejected electrons are now measured. Alright, okay, and we have a table for that. Write down the dependent variable. Good. It's an experiment, alright, or an investigation. An investigation. There are 3 variables. There is constant, there is dependent, and there is independent. Okay, I explained this in some other multiple choice. Independent. The word independent starts with I. So you need to ask yourself, what factor am I changing? What factor am I changing? Let's check something here. It says, a group of learners investigate the relationship, okay? The relationship between what? Work function Where is work function coming from? It's coming from the type of metal, all right, and kinetic energy. Now, in this case, you do not have a direct power over kinetic energy, but you can change the metal. Once you change the metal, I need you to notice the learners first use lead, then they changed. So if I was doing it, what would I have done? Check. My first experiment, I used lead metal. Then I changed lead into potassium. Then I changed potassium into silver. I changed all of this, which means that the metal becomes my independent. But I will not write metal. Under metal, what am I really changing when I change the metal? I am changing work function. So my independent variable is the work function. Now, when I change the metal, what does it affect? It affects kinetic what? Energy. It means my kinetic energy is dependent on the type of metal I used. I always like to write that EK is dependent on the work function of the metal. Do you see we've already answered the question? And the question said, we used ultraviolet rays in all of these experiments, which means my control is what? Frequency or energy of photon. My dependent kinetic what? Energy. Already question has been answered by us just explaining all of that. So write down one dependent variable. Write down the dependent variable, kinetic energy. Write down one control, frequency. All right? Frequency. Now, using the information in the table and without any calculation, identify the metal with the largest work function. Look, let me explain this. We don't have to write all the formulas here, but I need you to know this. E equals to work function minus kinetic what? Energy. If I move this over, we did this in the multiple choice, all right? Okay, let me say kinetic energy, therefore, all right, will be kinetic energy, therefore, as a plus, will be E minus what? Work function. Awesome. Now, this is a constant because we're dealing with the same light. For this one to be high, this value must be low. Check this. If 100 equals to 200, okay, let's say 300 minus 200. If I decrease this value to 150, what is my answer going to be? 150. Do you see this one now increased from 100 to 150? Which means EK is inversely proportional to work function. Now the question says, which one has the largest work function? We should go and check the one with the lowest kinetic energy, silver. So the correct answer is what? Silver. Explain the answer. Good. How do we explain this answer of work function in relation to kinetic what? Energy. All right. We will now say that kinetic energy is dependent on the work function. All right? Because the higher the work function, remember I said work function is the minimum. It means more energy is required and the leftover energy is available for the electrons. I hope this makes sense to you. Because more energy has been taken, all right, away in order to eject the electrons. So EK is actually a leftover energy. If you understand that, it's a leftover energy because EK is E, energy of photons, minus work what? Function. Done. Use the information in the table to calculate the work function of potassium. Okay, what do we know? We know the kinetic energy of photoelectrons with potassium to be 9,58 times 10 to the power negative 18. All right, by the way, remember we're given wavelength of the light as 2 times 10 to the power negative 8. What are we looking for? Work function. Quickly run to your formula, straightforward. E equals to work function plus kinetic energy. But because I'm given wavelength, I need to bring it here. On your formula page, this is written as Hc, all right, over wavelength equals to work function plus kinetic what? Energy. All right. Now, what is H? Planck's constant. It's there on the formula page. Please learn to copy the formula. What's my wavelength? It's 2 times 10 to the power negative 8. And that should be equal to work function plus 9,58 times 10 to the power negative 18. Okay, calculators quickly. Let's run to our calculators. What do we have? 6,63 times 10 to the power negative 34 times 3 times 10 to the power 8. All right. Over, my wavelength is 2 times 10 to the power negative 8. And my answer now is 9,945 times 10 to the power negative 18. Please do not round off. 9,945. 9,945 times 10 to the power negative 18. If I bring this over, it becomes 9,58 times 10 to the power negative 18. And that's your work function. All right, so let's go subtract quickly. And you are done with that question. Once you can do all of that, 9,58, all right, times 10 to the power negative 18, and you get 3,65 times 10 to the power negative 19, 3,65. So your wavelength is 3,65 times 10 to the power negative 19 meters. Sorry, we're not work function, and the unit of work is joules. 3,65 times 10 to the power negative 19 joules. All right. Now state how an increase in intensity. What is intensity? Intensity actually refers to how bright or dim. And with intensity, if it's bright, we talk about more photons. And here we talk about less what? Photons. Okay. One thing I need us to quickly remember is this. If there are more photons, it will eject more electrons. Kinetic energy remains the same. So what's my answer to this question? Remains the same, because they said, how will this affect the maximum kinetic energy? It doesn't affect the maximum kinetic energy. Explain your answer. All right. Increase in intensity, which I'm just repeating what I said, means more photons are radiated. The energy of the light remains the same because it's the same frequency. Therefore, more electrons with the same kinetic energy are ejected. All right, and we're done. Guys, this is a full paper done out of 150. Please check, rewind, watch it over, over and over again. Get hold of another paper, work through it, check the answers. You will notice that our answers are repeated from paper to paper. All right, so thank you for watching. It's been a pleasure to serve. It's been a pleasure to serve. Again, this production is done by Krazifizix. And just in case you need some of our materials, you can actually get some of our materials. We have our grade 10 material. All right. We have our grade 10 material, physical science for grade 10. Okay, which is a learner worksheet book. This allows you to do as many activities as possible. We have a grade 10. We also have a grade 11 material as well. All right. We have a grade 10. We have a grade 11, and that's it there. Which also, it's a worksheet book which allows you to do so many activities in class and as homework. All right. And then for physical science still, we do have our grade 12 material as well. All right, we have our grade 12 material, which is the textbook. It's a workbook. It has so many examples. It has so many questions. It has enough things for you to do. And in connection to that, we also have our maths books. All right. Okay, our maths books, paper 1, it's paper 1 and paper 2. We're taking a different approach. This one book is a book you use for 3 years. So it's good for you to get it in grade 10, use it in grade 11, and use it in grade 12. If you're in grade 11, you refer to grade 10. If you're in grade 12, you refer to 10 and 11. And they are NBT friendly. For those of you that you're going to be doing your national bench mock test, this book will help you. We've developed a whole lot of steps, ways to deal with mathematical creative issues. All right. Again, this is Bishop, and I'm signing out. I hope you have enjoyed this session of our paper review. Remember, get in touch with us. Get in contact with us as a school, as an individual. Join our extra class. All information right on our webpage, www.krazifizix.org.za. Thank you so much. God bless.